Welcome to the third lesson in Chapter 4 of the Pearson video series. This lesson introduces two strategies for proving that triangles are congruent and an often used strategy for proving parts of two triangles are congruent. The first theorem is called side angle side. This one says if two sides and the included angle in two triangles are congruent, then the two triangles are congruent. So right here we have two sides and the included angle. The included angle is the one formed by the two sides. So side, side, and the angle. Side, side, and the angle. Therefore, these two triangles are congruent using side, angle, side. Lots of combinations of congruent sides and angles show congruent triangles. Two that don't are angle, 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 and angle, side, side. An easy way to remember that these don't work is rule number 1. No AAA. And if you look here, we've got two equilateral triangles, and these equilateral triangles have the same angle measures, but clearly they're not congruent because the one inside is smaller. And then the other one, no cussing or writing inappropriate reasons for proofs on your paper. Okay, the second theorem that proves that congruent triangles is on the other side. This one is side, side, side. If three sides of one triangle are congruent to three sides of another, then the two triangles are congruent. So here we have two sides that are congruent, two more sides that are congruent, and three sides that are congruent. If all three sides of one triangle are congruent to the three sides of another, then those two triangles are going to be congruent. So let's take a look at determining congruent triangles. So in the first example, is there any additional information needed to show that triangle DEF and GHJ are congruent by side, angle, side? Okay, so I've got two sides here and two sides here. This angle that they're showing congruent is not in between these two sides. Okay, so to use this angle, we would need to show that side DE and GH are congruent. And then we would have the angle that's in between those two sides, or the angle that's formed by those two sides. So in order for side, angle, side to work, we would have to know that side DE is congruent to side GH. Okay, the other way that we could do this is if we knew that angle F was congruent to angle J. If angle F is congruent to angle J, then we have side, angle, side, and side, angle, side, and we can say that either one of those or that both of those are congruent. So those are two different reasons that are going to show that triangle DEF is congruent to triangle GHJ with the other information that we are given. Okay, let's take a look at the next one. In the second one, we have ABC and DEF, and we want to use side, angle, side. So for side, angle, side, and side, angle, side, we are going to need to know that these two sides are congruent. So we would have to say side AC is congruent to side DF, and if we know that, then we'll be able to say that the two triangles are congruent by side, angle, side. Now if we want to use side, 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 then we need to know that this third side is congruent. So if we know that BC is congruent to EF, then we're going to be able to say that the two triangles are congruent by side, side, side. Okay, and this one we can ignore because it is just like the first one that we just did. All right, well, let's go ahead and take a look at the second proof strategy, which we kind of skipped over. This one is called CPCTC, and CPCTC is a short way of saying that corresponding parts of congruent triangles are congruent. So this strategy says if you can show that two triangles are congruent, then you can say that any single parts of those triangles are congruent. And this is theorem 4.4. So generally speaking, in triangle proofs, triangle congruence is what you're trying to prove. If it isn't, then triangle congruence will be the goal and CPCTC will be the final reason. Let's look at the proof down below. Okay, so ABCDE is a regular polygon, which means that it has all the same sides. So looking over here, we are given that in our diagram. Okay, and then for some reason we know that two triangles are congruent by side angle side. So right here we have side angle side and side angle side. So we're going to say triangle ABC is congruent to triangle EDC. Okay, side angle side. So we can say that about both of those. And then AC is congruent to EC. So AC is right here, EC is right here, and those are congruent because those two triangles are congruent. So if these two triangles are congruent, then that means that each of their parts also have to be congruent. So we're going to use congruent parts of congruent triangles are congruent. And then finally, we want to prove that triangle ACE, that's this one right here, is an isosceles triangle. So triangle ACE is isosceles. And how do we know that? It has two sides that are congruent, which is the definition of an isosceles triangle. So we're going to say that's true by definition of an isosceles triangle. Okay, and that's all there is to side angle side and side side side. So see you later.